Okay, let us consider about spherical capacitors. What do you mean by a spherical capacitor? It is an arrangement with a sphere. This is one conducting spherical shell surrounded by the second conducting spherical shell. Let us consider that the inner surface of this one has got a charge Q. Let me take its radius as A and the radius of this one is B. The outer surface of the second sphere is Earth. As a result of having a charge Q, some charge will be induced on the outer sphere. Let us take this as sphere 1 and this is sphere 2. The charge on sphere 1 is Q, and let us arbitrarily take a charge Q dash on the second spherical shell. It's an assumption, I tell you. Let Q dash be the charge on the outer spherical shell. Now the first thing that we need to find out is the value of Q dash. And then the second thing we have to look at is where this Q dash is located. Let us find out the first one. What is the value of Q dash? What is the value of Q dash? This is the first part we need to solve. Okay. One thing I can say is that since the second sphere is Earth, the value of V2 is equal to 0. Since the second sphere is Earth, V2 is equal to 0. Now, what is the value of V2? Potential. V2 means potential at the surface of the second shell. V2 means potential at the surface of the second spherical shell. Now V2 is equal to 0. Okay, let's write the value of V2. What's going to be V2 is equal to KQ divided by B, that is a potential due to inner sphere at the surface of the second one, plus KQ dash divided by B. Now that is equal to 0, which will give you Q dash is equal to minus Q. So we found the value of Q dash. Now the second question comes is, where is this Q dash located? Is it on the inner surface or is it on the outer surface? That's a question to be answered. Is it on the inner surface of the spherical shell, outer shell, or on the outer surface of the spherical shell? For that, what we will do is we will consider Gauss's law. I am replicating this here, but in a smaller size. Okay, I am just considering the thickness of the outer shell. Outer surface is the Earth, as we know. This has got a charge Q. This has got a charge Q dash. Let us suppose that the inner surface of the spherical shell carries a charge Q1 and outer surface carries a charge Q2, such that Q1 from the conservation of charge, Q1 plus Q2 is equal to Q dash. I hope there is no doubt in that. Q1 plus Q2 is equal to Q dash. Now inner surface is assumed to have a charge Q1, outer surface is assumed to have a charge Q2. Total charge on the outer shell is Q dash, which means charge on the inner surface plus charge on the outer surface together is equal to Q dash. That's what I've taken. Considering a point inside the spherical conducting part of the spherical shell, say point P, we know that the electrostatic field at the point P is equal to 0. Why? Because electrostatic field inside a conductor is 0. Now let me construct a Gaussian surface passing through the point P. Constructing a Gaussian surface passing through the point P. What is the Okay, applying Gauss's law, closed integral EP dot ds is equal to charge enclosed by the Gaussian surface. Charge enclosed by the Gaussian surface. What is charge enclosed by this Gaussian surface? It is Q plus Q1 divided by epsilon 0. Now I will tell you this side of the equation is equal to 0. Why? Because electrostatic field at P is equal to 0. Electrostatic field not only at P equal to 0, if you take any point on this Gaussian surface, take any point on the Gaussian surface, what is the electrostatic field at that point? Taking any point on the Gaussian surface, the electrostatic field at every point on the Gaussian surface is equal to 0. Electrostatic field at every point on the Gaussian surface is equal to 0, which means Q1 is equal to, or Q1 plus Q is equal to 0, or Q1 is equal to minus Q. Now Q1 is equal to minus Q, and look from this equation, Q2 is equal to Q dash minus Q1. Already Q dash is equal to minus Q. Q1 also is equal to minus Q, which means minus Q minus minus Q, that is equal to 0. Okay, minus Q minus minus Q is equal to 0, which means where will this charge Q dash located? Q1, from here also we got Q1 is equal to Q dash. Q1 is equal to Q dash. Q dash is the Q1 is the charge on the inner surface of the spherical shell. That is equal to total charge on the spherical shell. In this case, I can now conclude that there will be no charge on the outer surface of the spherical shell. Okay, so I can just write it as, so if Q is the charge on the inner surface, the charge on the inner shell, the charge on the outer shell will be minus Q, and this minus Q will be located on the inner surface of the outer shell. I repeat, minus Q will be located on the inner surface of the outer shell. Ready? Okay. Just to say only, I wrote all these things. Okay, so now I will do one thing. I will distribute this plus Q all over the surface of the sphere. That is how the charge should remain according to the theory of electrostatic potential of electrostatics of conductors. And similarly, this minus Q will be distributed all over the surface of the inner surface of the shell. I mean minus Q only, minus charges here. Okay, sorry, this doesn't look minus. That again means what? There exists an electric field. You can see here, there is a region of positive charge here, there is a region of negative charge here. In this region, the electrostatic field is equal to 0 because that does not enclose any charge. If you consider a point here and construct a Gaussian surface, the Gaussian surface does not enclose any charge, so electrostatic field is equal to 0 here. Here also electrostatic field is equal to 0 because net charge enclosed by the Gaussian surface. If you construct a Gaussian surface here, you can see that the Gaussian surface does not enclose any charge because this is plus Q, this is minus Q. Total sum of the charges will become 0. In this region, electrostatic field is 0. In this region also, electrostatic field is 0. Then where is electrostatic field located? Electrostatic field is located in the region between the plates of the capacitor. Sorry, in the region between the spherical, the two spheres. There exists an electrostatic field between the spheres, which means there is a potential difference between the inner sphere and the outer sphere. Let us calculate that potential. This charge is plus Q as I said, this is minus Q as I said, plus Q is distributed on the outer surface of the inner shell and minus Q is distributed on the inner surface of the outer shell. Let us calculate the potential of sphere 1 using the theory. Potential at the surface of sphere 1, say V1. So due to the presence of this Q, the potential at the surface will be KQ divided by radius of that sphere, which is equal to A, plus the potential at the surface of the inner sphere due to charge on the outer sphere, we know it. This is K into, as every point of the sphere is located inside the sphere, the potential at all these points will be equal to potential on the surface of the sphere, which is K into minus Q divided by V. Right? Or I can say this is 1 by 4 pi epsilon 0. That is the value of K. Or Q divided by 4 pi epsilon 0 into 1 by A minus 1 by B. Now potential difference V is equal to V1 minus V2. Potential difference between inner sphere and outer sphere. The potential of the outer sphere is already equal to 0. So V1 minus V2, that is equal to, what is V1 is equal to? Q divided by 4 pi epsilon 0 into, I will take LCM here, B minus A divided by AB, B minus A divided by AB, this is V1 minus 0, right? That is equal to Q divided by 4 pi epsilon 0 into B minus A divided by AB. Already, there is a potential difference between the two shells. What is the formula for capacitance? C is equal to Q divided by the potential difference V. Q divided by V. Here V stands for the potential difference between the two spherical shells. Q by V. Now that is equal to Q divided by, what is V going to be? Already we have Q divided by 4 pi epsilon 0 into B minus A divided by AB, or C is equal to 4 pi epsilon 0 into AB divided by B minus A. How I got? I got by taking the reciprocal. This is the formula for the capacitance of a spherical capacitor. The capacitance of a spherical capacitor is given as C is equal to 4 pi epsilon 0 into AB by B minus A. Already? This is the answer for the capacitance of a spherical capacitor. From this relation, I hope it is clear to you. I hope all these ideas clear to you. From this relation, I can get the next idea. Shall I? I'm just wiping it off. As a case, okay, this much part is enough for me. Capacitance of an isolated sphere. Now the same idea I can use. Capacitance of an isolated sphere means I need to get the capacitance of the sphere of radius A carrying a charge Q. I will treat this also as a spherical capacitor with a second sphere located at infinity. Second sphere, where is second sphere located? Second sphere is located at infinity. Why? Because I have only one sphere to show you here. In this case, the potential V is equal to 1 by 4 pi epsilon 0 Q divided by A. Or capacitance is equal to Q by V. This terms will go to this side and we will come to this side. This is equal to 4 pi epsilon 0 A. This is the capacitance of an isolated sphere. You may be having some confusions with what I said, where I have to take the second sphere at infinity and all. Let me explain that point. Here what we got, the capacitance C is equal to 4 pi epsilon 0. Capacitance of the spherical capacitor is 4 pi epsilon 0 AB divided by B minus A. Right? Let me do one thing. This I will write as 4 pi epsilon 0 A divided by, I am taking this B to the denominator, B minus A divided by B. This will give you 4 pi epsilon 0 A into B by B is 1 minus A by B. 1 minus A by B. I told you, in order to get the capacitance of an isolated sphere, consider the radius of the second sphere to be infinity. Consider the radius of the second sphere to be infinity. That means if B is equal to infinity, B is equal to infinity, that means what is A by B is equal to 0. A by B is equal to 0. If A by B is equal to 0 implies 1 minus A by B, how much? 1. 1 minus A by B is equal to 1 means, what is the capacitance is equal to? 4 pi epsilon 0 A. Why I said this? Because there was a question earlier asked, capacitance of an isolated sphere can be obtained by second sphere of what radius? Answer is infinity. Take the radius of the second sphere to be infinity. This is how we can obtain the capacitance of an isolated sphere. So I hope this is clear to you. Thank you.